So for this review, we're finding x and y intercept. We have to identify if the function is linear, quadratic, constant, or other kind of function. And this one, can you see, this is a linear function because they have no exponents. And this will be represented by a straight line on the graph. The next step to find the graph, find the x-intercept. So x-intercept, to find x-intercept, you're going to make f of x equals 0. So 0 equals negative 5x plus 1. All right. And then you find x. You find x that makes this expression here equals to 0. What makes this equals to 0? Do you know what makes this equals to 0? You can apply, you can use addition property, multiplication property, and find out. Or if you have some practice, you already can see here, and you're gonna know that x needs to be equals to the 1 over 5, right? X needs to be equals to 1 over 5 because this needs to be equals to negative 1, negative 1 plus 1, 0. Negative 5x equals to negative 1 means x equals 1 over 5. If you don't know, let me know, type here in the chat box if you don't know how to find x. But you just have to apply addition property, multiplication property, and find an x that makes this equals to 0. Okay? So x-intercept equals 1 over 5. Next step, find y-intercept. Find y-intercept. The y-intercept you need to make now is not f of x equals 0. F of x equals to y. And x, you're going to make x equals to 0. Then that means y equals negative 5 times 0 plus 1. Negative 5 times 0 plus 1. This is 0. Y equals positive 1. Now we have x-intercept, we have y-intercept. Let's work on the graph. I will zoom in on the graph and let's plot, let's find x-intercept on the graph. I will represent a blue, and this 1 over 5. 1 over 5 is going to be somewhere here. 1 over 5. Okay? This is 1 over 5. This is the point that they're looking for. The next point is the y-intercept. It's on the y-axis. So get this green color here. Find y equals 1. And y equals 1 is here. This is y equals 1. And we know it's a linear function. So we will connect the dots with a straight line. A straight line connecting the dots. This is the representation. This is the line that represents the function f of x equals negative 5x plus 1. This is the line that represents the function f of x equals negative 5x plus 1. Oops, plus 1. Okay? Any questions about it? Let me fix this. It doesn't look nice. Plus 1. Kind of. Yeah. It's a little bit squeezed, but I think you can see. And on the test, you will not be asked to draw the graph. You'll not be asked because you don't have this tool on Microsoft Forms. You don't have this tool on Teams. But you might be asked to match. If I give you the x-intercept and if I give you the y-intercept, then you have to match with the right graph, like we've done before on the quizzes, okay? So remember how to find the x-intercept, how to find the y-intercept, and how to identify on the graph x, y-intercept, and if it's a linear function, how to identify the line. Any questions so far? Any questions? This is a review. If you have any questions at all, let me know. If you have any feedback, also let me know, because we are finishing. This is the last topic about linear equations in two variables and functions. And we will see a little bit of applications of functions. Functions are actually applied in several areas of knowledge. You can find functions on science, engineering, technology, economics, business, entertainment, everywhere. Functions have lots and lots and lots of applications. I'm going to show on the next slide, for instance, an application in sports. We can apply functions in sports, yes. Like here. Let me read this example that we have here. As of April 2006, the world record times for selected women's track and field racing events are shown in the table. So this is the table with real data, real times for each athlete that got that was winner in this distance, in this racing. Okay. The women's world record time t in seconds required to run x meters can be approximated by the function. So using this table here, someone actually found this function that can calculate the time, the function is time, based on the given distance. If you say the distance is 100, and then this is going to calculate, going to give you the time of 10.49, and so on. If the distance is 200, the time is going to be approximated 21.34, and so on. But why do we need the function? And that's the reason. If you want to find, and we don't have here on the table, the time needed for 500 meters is here between 400 and 800. You don't have on the table. You need to plug in and find out using the function. If you want to find out the time for 1200 meters, again, you don't have here on the table. You don't have 1200 meters here on the table. You have to plug in on the function and find out the right time, the approximate time using the function. How do we do this? How do we do this? Just a minute. For the first example, find the time required to run 500 meters. So A. Plug in T of 500 is going to be equal to 0.159 times what? 500 times 500 minus 10.79. Type this operation here on a calculator, and then you're going to find T500 equals, and let me make sure I get the right, 90.29. And you can check on your calculator to see if it's right. 90.29 seconds. Okay? This is going to be the time for 500. We don't have 500 here, but we know using the function, we are able to know this is going to be 90.29. What about the next example? T of 1200. We also don't have on the table, but we can calculate by using the function. 0.159 times 1200 minus 10.79. That means T 1200 equals, let me get the right answer here because I did the calculations before, 201.59. 201.59 seconds. Okay? And if you want to to check on the table, to fill out the table with the values that we found. 1200 is going to be 201.59. This is just an example, just an application, and as you can see, can be applied in sports. Lots and lots of applications of functions, and we will see a few more on our quiz. Okay, on our quiz, if you didn't understand yet, we will solve a few more questions like that on the quiz. Don't worry, we will actually work together if you need. That's it. Finish chapter 2. Hello, Julian. No problem. We just finished chapter 2 with the last topic, applications of functions. Now, before working on the quiz, let me see, and I think most of you are going to find the right answer for this bell work. What is the answer to the question? What is the result of the operation? The number represented by the yellow square minus the number represented by the blue circle equals to, and so the result is going to be 2 minus 1. 2 minus 1 equals 1. And you got the right answer. You all got the right answer. Thank you, Dariani. Thank you, Jan. Thank you, Danara. Thank you, Veronica, Adriana, Angel, Timothy, and Kimani. Thank you. That's the right answer. Thank you for participating. And as I told you, I was confident you all are going to get the right answer today. The right answer is going to be 1. And my pen is not working. But remember, the answer of the bell work is 1. All right, great. I'm happy that you got the right answer. Let's move to the quiz now. And this is yesterday's quiz, and this is today's quiz. Today's quiz is here. Let's check what we have for today's quiz. And we have 2 parts. First part is a review. From yesterday. So find the x-intercept of the following functions. Let me check the first example here. If we have a, letter A, f of a equals 13 times a. To find the x-intercept, we need to make the function equals to 0, right? So 0 equals 13 times a. And to make 13 times a equals to 0, we need to have a equals 0, right? A equals 0. The answer of the first one of the letter A is going to be A equals 0. And you're going to do the same thing for B, C, D, E, and F. Just be careful, because on E and on F, you're going to have 2 different answers, 2 different x-intercepts. And Timothy, yeah, that's right. That's right. No, it's just 1 over 3. You're only going to have 2 answers for E and F, because they are quadratic. If you have quadratic functions, you can have 2 answers. If you have linear functions, just 1 answer. Thank you, Timothy. Now the second part, let me show you the second part here. And for the second part, you're going to have applications of functions, have several applications. And the first one, let me read the first one. The height in feet of a ball that is dropped from an 80-feet building is given by, and this is the function that gives the height of the ball. H of t equals negative 16t squared plus 80. This is the function, where t is the time in seconds after the ball is dropped. Find the height after 1 second, and find the height after 2 seconds. What you're going to do here, get this 1 second. This is t equals 1. Plug in into the function. h of 1 is going to be equal negative 16 times 1 squared plus 80. And then you find the right answer. And type this calculation here, and you can use your calculator, right? Find the result and type here the right answer. For the next one, it's the same thing, but instead of 1 second, now t equals 2 seconds. 2. Plug in, then you're going to have h of 2 equals negative 16 times 2 squared plus 80. Oops, plus 80. Type in your calculator, find out the results, and type here the right answer. Oops. Type here the right answer. Okay? That's right, Timothy. That's right. D. That's right. D is going to be negative 2020. Now let's work. I'm going to give you actually a couple of minutes so you can work by yourselves. You can share your answers here as Timothy is doing. Thank you, Timothy. You can share your answers because you can help your classmates, you can help your colleagues. Share your answers on the chat box. And in a couple of minutes, I come back here and we can work together in the questions that you're struggling or that you're stuck. Okay? Let's work. Great. I'll be right back.